Hello guys, welcome back to my YouTube channel, and in today's video I'm going to show you how to convert an AC power to a DC power using a controlled rectifier and controlled bridge rectifier. So we'll try with the two each individually, and we will start with the controlled bridge rectifier. So let's start right away, and what we'll do first is connect our transformer to the power. And all we'll have to put the insulation cover over every cable. So now that we have insulated our cables, we'll have to measure the output power from the secondary winding. So let's measure the power and see the power that we have. And remember, this is still an AC power, but we just want to confirm the amount of voltage that we have. So you can measure the full voltage, which is around between 22 or between 24 and 27 volts. And remember, this is a neutral cable, so it allows you to divide the power into two. So I can divide the total, we can say it is 27 volts, we can divide into two to be almost 13, between 11 and 13. So that's half the total power, and that's the full power. So depending with the device that you are using, whether it's using a 12 volts, between 12 to 15 volts, or 24 to 30 volts, you will have to know how to connect between the three cables. So first we can start with our controlled bridge rectifier. Controlled means the diodes give out a specific amount of voltage and current, and uncontrolled means it gives you the output of the input you give it. So this is uncontrolled, which gives this uncontrolled rectifier, which gives you just the total amount of power that you give it. But for this other bridge rectifier, controlled bridge rectifier, you can see it has some readings. Like this one, it has a N539. So this one give you a 12 volts and 3 to 4 amperes. So you can calculate the total amount of power coming out of it. So let's start with this full wave rectification with our controlled bridge rectifier. Now guys, we have our bridge rectifier connected, and just to explain a little bit about how it works, as you know, these are just diodes connected, and a diode allows current to flow in a certain direction. And in our diodes, the shaded part means the negative point. So it means a current only flows when it's connected, the negative terminal is connected to the negative part. So, and the other part, which is not shaded, means the positive terminal has to be connected to it for the current to flow through the diode. And now taking this as this is now our power supply, and as you know, an alternating current means it shifts from positive to negative at intervals. So how the rectification works is when the positive terminal passes through this, when the positive current passes through this point, it will have one path to go through it, and this will be the path. So it will pass through this diode, which is not shaded because this side is the positive terminal. So it will pass through this, coming out from this point and through the cable. This is now a positive terminal, and when it passes through the other side, this other cable, it will also pass through this diode and accumulate on this other end, which is still our positive terminal. But when it is a negative, we come back to the first cable. If it's a negative current or a negative terminal, it comes through this other diode here, which is shaded white, or the negative, or that allows a negative current to flow through it. So it will flow through this point and come to the negative, to our negative terminal here. And when it comes to this other cable, it will also flow through this diode, which has a negative shaded part. So this will be our negative terminal, and this will be a positive terminal. And remember, there is no wave which is not rectified, so it is a full wave rectifier, which means when the current flows through the positive direction, all of it is rectified, and when it flows through the negative, as a negative current, it will also be rectified. So we have our full wave rectifier here, but regulated. It allows up to a certain amount of power to pass through it, no matter what power you supply with the transformer. So after that point, we still have some AC current passing through it, and we have to add a filter capacitor. Taking this as our example, filter capacitor, we can just connect it across the cables. And as you can see, this is the shaded part, or the negative part. So the negative part will be connected to the negative, and the positive connected to the positive terminal. So let's do it quick. So guys, we have connected our filter capacitor. These are 2200 microfarads and 25 volts maximum. This is just for testing, but this is how you can connect it typically, but you have to follow some dimensions depending on the device you are connecting with it. So it is rectified at this point, and then it passes through a filter capacitor, and at this end we will now have our direct current, our filtered direct current. So we can just connect it to the power and test it by ourselves. So as we had said, this will be our positive end, and these are connected like. Let's connect it and see. So as you can see, there we have our final positive, final direct current. That is a full wave rectification. But after that, we have just done the full wave rectification and filtered our voltage using the controlled rectifier. So let's try out with this one, with the uncontrolled rectifier. And as you can see, using the uncontrolled rectifier is much easier because we have all the dimensions, all the details written properly. So we have the positive terminal and the negative terminal, which is after rectification, and then we have the side for the AC. So this is our positive terminal, our negative terminal, meaning the outer pins are for the rectified power, while this one, the AC, means the two in the middle, this one and this one, 1 and 2, you just connect them to the AC and it will be rectified and be distributed between the two cables. So let's connect our AC power to the two AC terminals. So now we have connected our AC terminals. We just need to connect the positive terminal to this point and the negative terminal to this point, and that will be our DC output.
Action.
And now guys, we have all set. We just need to connect it to the power and see if we have a direct current output here. So this is the positive terminal and this is the negative, and as you can see we have our power there. And 35 volts, that's the output power. So as you can see, this is the positive terminal and this is the negative terminal, and these are for the AC. As simple as that. This one is over the counter material that you can buy. We have completed our project converting an AC power to a DC power using bridge rectifiers. Make sure to subscribe, share and like for more updates. Thank you.